learning target 9 is properties of logarithms, which are very similar to properties of exponents because they're inverses of each other. All right. There's only 4. I'm going to start with the one on the bottom because it's the most obvious of the 4. And then I'll go back and talk about the other 3. Okay? So the first property is the property of equality. And it says, if you have a log with the same base on either side of an equal sign, so we're trying to solve an equation, then we don't have to worry about the log base part. We can just set each of the values equal to each other. That's just like what we did with exponents in learning target 3. All right, in learning target 3, we said we have 3 to the x power equals 3 to the 5th power. Well, since the bases are the same, to solve the equation, I'm really only worried about the exponent. Right? So same idea here. I'm only worried about what's at the end of the log, those values, because the bases are the same. I feel like that makes sense. Yes? No questions about how that works. They have an example over here. You have log base 8 in both of these, so we can just leave the log base 8 part out of it to solve the equation. Any questions about the property of equality? All right. The other 3 properties are opposite of what you do with exponents because we have an inverse function. Right? So what's going to happen, in order to do learning target 9, you're solving equations. In order to solve an equation, you have to have one log on both sides of the equal sign. You can't have multiple. Right? So you have to have log of the same base, one on each side. So what's going to happen is they're going to give you multiple ones. So for example, they're going to say log base 3 of 9 plus log base 3 of x equals log base 3 of some other number or something. I can't solve anything until I condense that into one logarithm. All right, so I must make it into 1. So again, it's the opposite of exponent. So with exponents, when did you add the exponent? When you had 2 bases being multiplied together, right? Here, when you have 2 bases being added together, you multiply the values. Okay? So that's all that definition says. It just says if you have 2 logs being added, you multiply those values to condense it into 1. All right? I think this will make a lot more sense when you practice in a second, too. Then the quotient property. Again, you'll have log base, this is a fourth of 4, minus log base, a fourth of 5. When you did exponent rules, when did you subtract? When you were dividing the same bases, right? So in this case, if you're subtracting 2 logs, then you're going to divide those values. Okay? And then the last one is the power property. So if you have some value times the log of something, we need to condense that so it just says the log of. We don't want to have anything in front of it. So that value is actually the exponent for your logarithm. So I can change the x to 8 to the x power, right? So I don't want to have anything in the front. So in learning target 9, we're solving equations, and we're using these properties to solve them. Okay? For practice, there's 4 on your note sheet to practice. Now, here's the thing. All those properties I just talked about, you only need them if there's a logarithm on both sides of the equal sign. If there's not a logarithm on both sides of the equal sign, then you shouldn't use those properties. You should use ideas we've already talked about. So for example, in the very first question up here, there is not a logarithm on each side. So the easiest way to solve this is to rewrite it like we did in learning target 7. So if I rewrite this as an exponential like we did learning target 7, what does this end up being? What does it say? 2 to the 5th equals x. Right, just like learning target 7. Well, 2 to the 5th is 32. So x is 32. That involved no log properties because there wasn't a log on both sides. So don't get caught up in thinking you have to do the properties every single time. Only use log properties if there's logarithms on both sides of the equal sign. Everyone clear on that? All right, on the next one. We have log base 7 of n equals 2/3 log base 7 of 8. We could almost just solve it from here, except there's a 2/3. I can't solve this until I somehow simplify and get the 2/3 to be part of the log. So I use the power property of log base 7 of n equals log base 7 of 8 to the 2/3 power. Or that value in the front becomes the exponent. Now that I have that, I can drop the log base 7 part, because they're both the same base, and I just have n equals 8 to the 2/3. Now you can type that into your calculator, or you can rewrite it. So the cubed root of 8 is 2, and 2 to the second power is 4. Or you could just type in 8 to the 2/3 in your calculator. You also get 4. Questions about that one? See, in that one you had a log on each side, so you had to use the property. All right, back down here then. Log base 6 of the quantity 4x plus 4 equals log base 6 of 64. Do I have to use any properties besides that of equality? Do we have one log on each side? Yes. So because of that, we can just kind of drop that off and solve what we have. We have 4x plus 4 equals 64. There's nothing extra to do. There are no values out in front of the log. We need to make exponents. We just need to drop off what we have. So I solve this. You get 4x equals 60. So x equals 15. Is that a problem? All right. Then the last one kind of puts it all together. So in the last one, we have multiple logs on the left-hand side. I cannot do anything until I have one logarithm on the left-hand side. I have to condense it into one. In order to do that, I need to have logs without these values in the front. So the first thing I need to do is rewrite those logarithms so that I can, with the exponents, using the power property, so that I can condense later. So I can rewrite this as log base 6 of 4 squared minus log base 6 of 16 to the 1/4 Any questions about that step? Then I can go ahead and simplify what that is. That's log base 6 of 16 minus log base 6 of 2, 4th root of 16. Again, to solve this, I have to have one logarithm on each side. So I have to condense this side. I have to change this into one logarithm. So if I'm subtracting two logs and I want to condense it into one, what happens to the values? Divide it, because we're subtracting, right? So we have log base 6 of 16 over 2, which we all know is just 8. So we have log base 6 on both sides, so we use the equality property, and so now I know that x equals 8. Questions about that? That's what Learn Target 9 homework is. It's taking equations involving logarithms, and you're going to solve them. So again, it could be like the first one. There's no logs on both sides. There's one on one side, so we need to rewrite it as an exponential and go from there. Or it could be like the others, where there's multiple logs. You need to condense things or rewrite things so you can solve the equation.